Alright, so this could be a video on how to complete proofs. And these are just where you take an answer, and you're given the answer, and you kind of know it's true from what you've learned in geometry, but then you have to explain what makes it true. And really where these really become important is with triangles. And we're going to kind of do this part of it first, and then with lines and segments and angles, then we're going to transfer this to triangles eventually. So we look at this here. We have two lines, line GH, or GJ, I'm sorry, and DF. Okay, and they have some points in between the main part of the line, or the main part of the segment actually, it's not a line. And in these proofs, it'll always have it'll give us some givens, okay? Because we could look at this line GJ, and we could look at DF, and we could say, yeah, they're probably congruent or the same, but we can't be sure. So in the proof, it has to tell you some things that are givens. So here the given is DF equals GJ. So then we know these lengths, DF and GJ, are the same. They're equal to each other. And also, EF is equal to GH. So we know this little line part of the section here is also equal to this section here. And we could probably think in our mind that, well, if these two are equal to each other and these two are equal to each other, there's only two sections left, they must be equal to each other as well. And that's what it wants us to prove, DE equals HG. There's some ways around this. When you do these, you're going to have some statements. You're going to do it. This is called a two-column proof. And it's going to give you some statements when you first start doing these. And the first thing it's going to have you do is it's going to give you the statements, and you're going to say what is the reason that those are true. And you just have to remember from some of the things you learned about segments and such, and I'm going to kind of go over this here as we go. So keep that in mind. I'll kind of guide you through this. So let's look at these and go through this first proof here. So here we have, these are our givens. Sometimes it starts with the given. This isn't a given. Okay, but it does tell us DF equals DE plus EF. That's a statement. This whole thing is equal to DE plus EF. Okay? And what that means is, you think about what you're doing here, this whole section is equal to DE plus EF, and that's we're just adding the segments. So then the reason that this is true is because of something called segment addition. And that's a property. It should be in your textbook. So segment addition, that's going to be your property. And as you're looking through the lesson, you should keep that in mind, that there's these properties that you're going to have to kind of become familiar with. And hopefully you've seen these already. So segment addition property. You're going to look at the next one here, GJ. Kind of does the same thing. GJ is equal to these two sections, so we know it's another segment addition property. And also to keep in mind, when you give a reason, sometimes it's going to ask you based on what other line. Well, these aren't based on any line at all. They're based on what you know about segments. And if you add them together, two shorter sections of the same segment, they're equal to that larger section. So this is segment addition property. Now it's going to give you DF equals GJ. And when you see something like this, you might want to say, well, is that a given that they gave me? You look up here, DF equals GJ. So that's a given. And when they give you something like this, it's going to be used for something else later on. Okay? And let's look and see what it's saying. DF equals GJ. So DF, this whole thing, equals this, right? So we know they're equal to each other. And then look what it does underneath. It then takes DF and GJ and turns them into this. Okay? You might ask, well, what's going on here? First we had DF, now we have DE and EF. So it's really saying this longer section is equal to the two shorter sections. And then this GJ, this longer section, is equal to these two shorter sections. Okay? So what are we doing? We're taking out DF and we're substituting in these two shorter sections. Same thing here. We're taking out GJ and we're substituting in these two shorter sections. So we're doing the substitution property. And this one, though, is based on something, right? So it's based on the given, line 3, because we know these two lines are equal to each other. So if these two line segments are equal to each other, then their little shorter sections are also equal to the other two short sections as well. So we know it's at least this one, but we also know from this statement, this segment addition property that we used, we can also say we got this GJ, right, comes from this, and this DE comes from this, right? So we're going to use line 1, 2, and 3. So we're going to note that when we're completing it. So that gets us to here, right? And you say, well, what in the world? Why am I even here? Why am I going this direction? Well, you're going to see here, it's really helpful to get all these things in here. Because now we're going to see another short one, EF equals GH. And again, when you see this short one, you might want to go back to the given. And there it is, EF equals GH. And you say, well, why are they telling me that? Right? And maybe you can look ahead and see. If you think about this, so if EF equals GH, so if this one equals this one, right? We can substitute, if we have GH, we can substitute EF for it. Or if we have GH, we can substitute EF, right? So we can switch these back and forth for each other. They're the same thing. So we want to look at, what do we want to end up with? DE and HG. We have a DE right here already. So if we want to get DE by itself, and we need HJ, right? That's what we're going for. We got to get this by itself, right? So how do we get rid of this EF right here, right? Well, we do it because we know these are equal to each other. So EF is equal to GH. So we put this given in here first, and since this is a given that these are equal to each other, we can get rid of the EF and we put the GH in. Then we have DE plus GH equals GH plus HJ. And then we have these two that are the same. These are the two we want to solve for. And then we use the idea of, in algebra, if we have these two things on opposite sides, we can subtract one side from the other and eliminate them, right? So that's what we're going to do. And this is called, I got ahead of myself. So this one here, substitution is going to be down here. But this is going to be a substitution. So we know that EF equals GH, so we're going to plug in wherever EF is up here, we're going to plug in the GH for it. See right here? We're just taking out the EF, putting in GH because of that given. That's substitution again. And then we end up with, this is where then, once we have this substitution in here, we have the GH and GH on both sides. We can then subtract one from the other. This is going to be the addition subtraction property. And that will eliminate those. And we end up with DE equals HJ. That's kind of how we do this. We just start. With these ones, are going to be not too bad at first. They shouldn't be. You should be able to logically work these through. It's going to give you the statements. Remember these really important ones over here. Segment addition property is really a common one for segments. This substitution property, where if one thing like EF equals GH, we can, wherever EF is, we can always put in GH. Wherever GH is, we can always put EF. And then we can use this addition subtraction property to eliminate them and get exactly what we want. I hope this helps you understand these. We'll do one in class tomorrow if you'd like to do another one. And let me know how if this helped you or not. You can even watch this tonight, send me an email with any questions you have as well, Thomas. So see you in class.